Here's our first example. This method takes an array of integers and prints the first item on the console. It doesn't matter how big the array is. We can have an array with 1 or 1 million items. All we are doing here is printing the first item. So this method has a single operation and takes a constant amount of time to run. We don't care about the exact execution time in milliseconds because that can be different from one machine to another or even on the same machine. All we care about is that this method runs in constant time and we represent it using the big O of 1. This is the runtime complexity of this method. So in this example, the size of our input doesn't matter. This method will always run in constant time or big O of 1. Now, what if we duplicate this line? Here we have two operations. Both these operations run in constant time. So the runtime complexity of this method is big O of 2. Now, when talking about the runtime complexity, we don't really care about the number of operations. We just want to know how much of the algorithm slows down as the input grows larger. So in this example, whether we have 1 or 1 million items, our method runs in constant time. So we can simplify this by writing down O of 1, meaning constant time. Let's look at another example next.